Okay, today we're going to be learning about something called isotopes. So we're going to learn about isotopes, and to do that we're going to use a nuclear symbol. So first off, something you just need to know is that, for example, let's look at hydrogen. It's the very first one, okay? Its atomic number is 1, and it's the very first one. And it could have an isotope of 2, okay? So let's just talk about that. Let's talk about helium. Helium's element number 2, and it's atomic number 2, or element number 2, right? And it has a common isotope, I think, of 4. And what does that mean? So let's talk about this. Now, the way we're going to do it today, by the way, is we're going to write this a little differently. I'm just writing it like this today, right now in this format. But we'll do the hyphenated format today. But today we're just going to, let me first just look at it like this. So this is the atomic number. This is atomic number. Don't even worry about it. That's super easy. You just go over here to the periodic table, where right here, the periodic table. Where is it? Common isotopes. Here we go. And if you look at hydrogen right here, it's atomic number 1. And helium is atomic number 2. So that's just straightforward. But what you need to know is, what does that mean? So this means that protons, number of protons, is equal to 1. So if you have an atom and it has a proton inside of it, okay, so deep in its nucleus, so you have the, let's say, electrons flying around out here. You know what you've seen atoms before, right? They have these, cool little electrons and these little negative electrons. Let's not worry about those right now. But there's this nucleus right here, right, in the center. That nucleus has neutrons and it has protons, okay? The number of protons it has determines what element it is. I don't care how heavy this whole thing is. I don't really care that much. If it has 1 proton, then it's hydrogen. If it has 2 protons, then it's helium. And if it has 6, it has to be carbon. See how carbon is number 6 right here? Carbon is number 6. Oh, by the way, the number was up here on top. I was referring to that number. So there's the number on top. So if it had 8 protons, it has to be oxygen. I don't care about anything else. I don't care how many electrons it has. I don't care how many neutrons it has. If it has 8 protons, it's definitely oxygen. And if it has 9 protons, it's fluorine. Okay? And so on and so forth. All right, now, looking at that, what is this other number? This is the atomic mass. So this is the atomic mass right here. And what is atomic mass? That's the number of protons and neutrons, okay? Well, how many protons does hydrogen have? Well, it has to have 1. It's hydrogen, right? It has to. If its atomic mass is 2, then we know that the number of neutrons is equal to 1 then, because 1 plus 1 is equal to 2. So pretty much all you have to do is take this number and subtract that number, and that'll tell you the number of neutrons. So take this number 4, take away 2, and now we know that this one has 2 neutrons. Just take that number, because this is all the protons and neutrons, and just subtract the protons. It'd be like, if there was I don't know, if you had bubble gums and there was blue and red ones, and this is how many there are altogether, and this is how many blue ones, well, then you could figure out how many red ones, right? You subtract them. So it's very similar, same thing, okay? So, but today we're going to look at a different format. So we're going to look at something like this, carbon-14. A lot of times they just write them like this, okay? Or oxygen 16. Okay, they might just do it like that. And that's because we already know what carbon is. Carbon's number 6 on the periodic table. You could just go look at the periodic table and go, carbon is number 6, oxygen is number 8, and so on and so forth. So, carbon is 14. So then, okay, carbon is number 6. So we already know that the number of protons is equal to 6. And the number of neutrons for this isotope, and I'll talk about that in a second. For this isotope, What's 14 minus 6? Well, it's 8. So there must be 8 neutrons. Because remember, this is actually the atomic mass, and that's how much neutrons. This is the number of protons and neutrons. How do we know how many protons carbon has? Just go look at the atomic number. It's number 6 on the periodic table, so there's 6 protons, straightforward. Neutrons, well, we just have to subtract 6 from 14, and that'll tell us how many neutrons are. And that's all you have to do. Let's do oxygen. Number of protons, well, oxygen is number 8. Go look at the periodic table if you don't believe me. It is 8. How many neutrons does this one have? Well, 16 minus 8, it's 8. So this one has 8 neutrons. Now, if they ask you, is this the most common isotope right here? This one? So is this the most common isotope? And before I even answer that question, let's talk about what an isotope is. Well, it turns out that the atomic mass of carbon-14 is, where's my pencil here? Of carbon-14 is this particular, and the mass of this one is 14. But there are such thing as carbon-12. Okay, there is such thing as carbon-12. In fact, what is the most common isotope of carbon? Most common isotope of carbon, it says, is carbon-12. The most common carbon isotope is carbon-12. Okay? As it says there are other isotopes, though. There's carbon-13, there's carbon-14, and so on and so forth. So let me explain what that means. Let's look at the atomic mass of carbon. So here's carbon. What's the atomic mass? 12.011? What? How is it like? The funny thing is the atomic mass is how many protons and neutrons it has. So it should be a whole number. 12, 13, 14, 15, 16, 10, 9, whatever, right? 14. Why is it not? Why is it like point something? Why is there a fraction here? That's because if you grab a bunch of carbon from Earth, you just grab it, it's gonna have all kinds of different isotopes in it. This is the average of all of it. So that way, when we grab a bunch of random carbon, we know how much it should weigh, because we know that in real life, it looks like most carbons are 12. That's why it's really close to the number 12. Notice that? But there are 13s and 14s, which raise it up a little bit. That's why it's a little over 12. Look at oxygen. What do you think its most common isotope is, everybody? We think it's probably 16. It's really close to 16, right? But the average of all of the oxygens is 15.999, which tells me there must be some oxygen 15s out there, to bring this down a little bit. But it's really close to 16, which tells me that most of them are 16, okay? And that's why if you want to know the most common isotopes, you could probably just look at this in most cases and just look it up and see what number this is close to. For example, if you go to uranium, way down here on the bottom, number 92, 238.03. So the most common isotope is 238 actually, okay? But there are 239s obviously because it's higher. But just to let you know, there are 235s as well, and that's the one they make nuclear bombs out of. And it's very hard to find those ones, and that's why it's so hard to make a nuclear bomb. When you pull a bunch of uranium out of the ground, most of it's not useful for a bomb. Like by far, like 1 in 1,000, 1 in 10,000 atoms are only useful for it. So that's why it's so hard for somebody to just find some uranium and make a bomb out of it. It's really hard. So you don't have to worry about somebody just grabbing some random uranium. It's got to be filtered out. So this is 238 isotope. That's the most common one. So let's look at oxygen. If I looked it up, what is the most common isotope of oxygen? And it says it's 16, which is right. But there's some heavy ones that are 18, and there's also plenty of light ones, obviously, because the average is 15.999. So it says is the most common isotope found in nature, followed by a much lesser amount of heavy 18s. So it looks like there's some 18s as well. So and those are considered heavy ones. All right. But the average is 15.999. So if you're wondering what the most common isotope is, just go look at the periodic table here and look what number it's really close to. For example, this one's really close to 31, so 31 is going to be the most common isotope. This one, the common isotope is going to be 27. This one's going to be 28. This one's going to be, germanium. I'm not sure. You might want to look that one up on the internet. It's like 0.6. So it might be 73, but I'd look that up just to make sure. And because once they get bigger, it is a little harder because there's so many different isotopes out there. But going back here, that's all there is to this, is just look up the atomic number, and that tells you how many protons, and then take the mass and subtract that away, and that tells you how many neutrons. Because remember, this number right here is how many protons and neutrons. And that's all there is to it, folks.